Hey there, my name's Ryan. I'm a web developer working in Chicago, and today I want to show you Elm. It's a language that I'm super into. My internet's been giving me trouble, so if this doesn't work at some point in the video, um, I'm not even mad. I was asking for it. Start a video series when the internet's down. Um, but basically, Elm is a language that compiles down to JavaScript, HTML, and CSS. So if you're new to programming, it's a really great way to get started without having learned three separate languages and deal with kind of three separate ecosystems and different build tools and all that stuff. Um, I think this is gonna work. It'll work. Wait. Okay, cool. So I've got Elm installed locally. So what we're going to do is we're going to ignore the fact that my internet does not work at all. Um, yep, we'll ignore it. And we'll just hop straight to it. So to kind of show you guys what the syntax looks like. The syntax is the number one way to scare people away from Elm because it doesn't look like JavaScript or CSS or HTML. Not that any of those languages look similar, but if you're coming from a Java or a C Sharp or a JavaScript background like I did, this stuff might look weird to you. Yep, internet just went down again, so we're just going to close this tab. Okay, so to get started with Elm, if you have Node installed already, I've got Node version 8.11, but anything greater than 6 or 4 or whatever should work. All you're going to run is npm install -g elm, and that'll basically pull down the Elm command line tool so that you can get up and running and start doing all the cool command stuff that we're doing today. So one of the things that you should see when everything's working is when you run Elm, you should see this message. Hi, thank you for trying Elm 19. So these are pretty common commands. They list them out here. We're going to start with the Elm REPL so that we can get used to the commands or the kind of syntax of Elm and kind of see what it does. And then we can do Elm init to create our own project, and then Elm Reactor, which is going to make it so that we can pop something up in our browser and actually start to see our Elm code in the web. So Elm was designed for making user interfaces in the browser, so it compiles down to the browser technologies. But yeah, let's start with the Elm REPL. And I'm just going to do Command L to clear my screen. And let's just start writing some Elm code. So the first thing you might want to know about Elm is what's available. So we've got strings. So strings are just like words or sentences or things like that. And so basically, if you put something in double quotes, that's going to be a string. And that string is going to basically be able, you can concatenate strings together. So I could say, Ryan plus plus, Haskell, and that would create one string called Ryan Haskell. I think this works better when I have an internet connection. There we go. Cool. So we've got Ryan here. If I wanted to do Ryan plus plus space plus plus Haskell, this is how you put strings together in Elm. So you might be used to doing this in another language like JavaScript or C or one of those. But if you try that in Elm, it'll actually let you know, hey, I can't do addition with string values. So the plus operator in Elm is actually addition, and plus plus is concatenation, and it even gives you a hint. So this is an example of an Elm error message. So I'm going to zoom in a little bit here so you can see a little bit better what's going on. I'll make this full screen too. These are the kind of error messages that you get to see when you use Elm. They're super friendly. They usually will reference you to a better suggestion, or sometimes they'll even reference you to the Elmlang website to take a better look at the error message. So here it's saying we should use the plus plus operator for that. So that is the first weird thing that you'll notice about Elm. Elm's not the first language to do this, but it's definitely not very common in languages that kind of derive from the C syntax. Cool. So those are strings. You also have characters. So a character is just a single letter. And here you see when I run this, it'll actually print out what's known as the type. Elm's a typed language. We'll get into that later. It's not that important, but that's what allows us to have no runtime exceptions in practice. So it's kind of exciting. So yeah, so there's types. You've got things like floats, which are basically numbers that can have decimals, and then you've got integers. It prints out as number here because 1, 2, 3 could actually be an int or a float. It's not that important, but integers are like whole numbers. We also have booleans. Another weird thing that you might notice is the booleans have capital letters, and they're of type bool. So basically, we'll get back to why these are capitalized later. But those are the true and false are kind of like a custom type. They're a little bit different than booleans in other languages, where they might be stored as like a 1 or 0. But we'll circle back to that later, and you'll see how you can make your own custom types. It's actually one of the cool parts of the language. We also have lists, so we can have a list of numbers, 1, 2, 3. You see that says list of number. We can have a list of strings. So we use these square brackets to denote a list. What you cannot do is you cannot mix a string and a number. It'll let you know. It'll say lists can only have the same type. So second element of this list does not match all the previous elements, and it'll underline which one's different. Second number is a number of type number, but all the previous elements in the list are string. So there's a hint for us saying, hey, everything needs to be the same. That way, it's you don't run into unexpected things halfway through, like looping. It's kind of a useful thing, but it even recommends, hey, like if you want these to all be strings, maybe we can convert this to a string. So this is a function. We'll get to functions in a little bit, but functions allow you to take in a value and return a value, and that's what Elm's all about. So I'll clear the screen again. So we saw lists, we saw strings, we saw numbers, booleans. Now I'm going to show you guys records. So records are kind of like objects. So this is just an empty record. You'll notice, unlike JavaScript, we're going to use an equal sign to assign a value to a key. The equal sign consistently means the same thing in Elm. And the type of this is it's a record where there's a key name, which is of type string. So if I had an age, you'll see that this is, age is a number, name is a string, and that's the kind of type of thing that this record is. So you can create records of any type, and it'll automatically infer the types based on what it knows. It knows Ryan is a string, it knows 25 is a number, so it knows that this name property is a string, age is a thing, and this is a record. And Elm does all that work for you and kind of builds that stuff up. So everything I showed you, those all compose. So you can have a list of names, you can have a list of records if you want, and basically that's gonna be a list of that record type. You can have a list of booleans or whatever, and just like I said earlier, everything's gonna be the same type. So if you have, one item in the list is saying name is a string and another one's saying name's a boolean, Elm will let you know. So when you're looping through, you never have to worry about running into a weird thing. You might notice what I didn't show you was null. That's not a thing in Elm. So there's no null in Elm. The way they handle it's a little bit different, but it's kind of cool. So there's no runtime exceptions in Elm. So if we just had null somewhere in here, you'll see it's not even a thing. It's going to say, hey, did you try to say not, or abs, or these other functions that are kind of as close as they can get to null. But you'll notice when we're looping through things in JavaScript, or we're dealing with empty values, null is usually a place where you'll have a runtime exception, null or undefined. And so Elm handles that a little bit differently, so we don't have to worry about that stuff. So those are values, and then the other thing in Elm that's important is functions. So if you're coming from JavaScript, I'm going to make a new tab here, and I'm going to open up a node. So this is the same thing, the same kind of thing that we did with Elm. We've got a node REPL now. So we're going to be doing this over here is JavaScript, and then we'll have Elm over here. So adding two numbers together, That's what it looks like in Elm. So it looks like in JavaScript, not too different. And so if we want to make a function called add, in JavaScript you might do something like this. Add, it takes in an A and a B, and it's going to return A plus B. And so when I want to call add, I'll say the name of the function, and then in parentheses I'll give it its arguments, right? So I'll say I want to add 1 and 2, and that'll give me 3. In Elm, there's a lot less syntax than this, a lot less stuff to remember. How Elm functions work is you give the name of the function, and then you're going to separate all the inputs it's going to take by spaces. So add, if I want to add A and B, I say add AB, and then I say what I want that to return on the right side. So everything in Elm, every function is going to return a value, so I don't need to type out a return keyword or anything like that. I can just say what the value is I want to return. In the case of add, I just want to return A plus B. So this is defining the same function in Elm, and you can kind of look at this weird thing it's spat out. Not that important now, but when I want to give it arguments, I can say add 1 and 2, and that's going to basically set A to 1, and it's going to set B to 2, and it's going to run 1 plus 2, and that's what's going to give us our value 3. So similar idea to JavaScript, but just a little bit different how it works out. Curious if I could split, but I guess not. So another simple example of a function you might make is double, which can take in a number, and I'm just going to do this all in one line. It's going to return the number times 2. So I call double on 10, we should get 20, right? So in Elm, it's the same idea, right? We're going to say the name of the function, double. We're going to say the inputs separated by spaces, and then we're going to say what we want to return. So here we can do num times 2, right? So these are our arguments. This is the name, and we hit enter. We get another function type signature, which is interesting. We'll take a look at why there's arrows here very soon. It's something that's very weird, but when you realize what it does, it's like, oh, that's actually kind of neat. You start doing pretty cool things. So just like in JavaScript, instead of having to put parentheses around it, in Elm, parentheses are optional, and they go around individual values. So it would look really weird if we wanted to do parentheses. We turned out we only use parentheses in Elm to separate ambiguity between white space. So you can always wrap a value in parentheses, but it doesn't really mean anything, so you won't really see that in practice. So yeah, when we do double 10, we get 20, just like we did in JavaScript. Turns out math works the same across languages, except for some weird things that you see. There's something called nan over here. We're not going to get into that. That's JavaScript magic. But yeah, so that's kind of how you make a function. You can make functions or anything. So here we had a number and a number. It returned a number. Here in double, we take in a number, we return a number. So why this weird type signature, right? Why does add have number, arrow, number, arrow, number? And why does double have number, arrow, number? Well, it turns out that every time we provide a value on the left, we're going to get the value on the right. So if we give double a number, it's going to give us a number, right? That makes sense. So if I give double 10, which is a number, it'll give us 20, which is a number. With Elm, every argument can be taken in one at a time. It doesn't auto fill out nulls. So what we can say with add is if it takes in a number, gives you a number. If we just give it one number, what we're going to get back is a function waiting for the next one. So if we do add 1, we actually get a function back. We don't get what we might get in JavaScript, which is nan. And the reason we get nan is because JavaScript automatically is going to pass in all the arguments you're missing as undefined. So what ends up happening is we're really doing this under the hood, and that's what's giving us this weird value. So with Elm, we actually have a function we can still use. So to make this more clear why this might be useful, if I say add 100, that's a new function, I can say that's just going to be whatever the value of add 100 is. So now add 100 is a function, that's waiting for one more number. So I can call it just like a function. So this is a little unusual, it's a little strange, but as we use Elm more and more, we're going to see this pattern. We're like, oh, that's kind of cool. It's kind of nice. What I typed up here is the same thing as typing in you know, add 100 taking an argument and putting it at the end here. So when we give add 100 number, it's actually going to call add and 100. This is essentially, we don't need to list the last arguments in Elm. And that's because of the way that add works. So 3100, we basically have these functions that we can build out of smaller functions. So that's kind of how functions work. So if you want to do something useful with Elm, you probably aren't going to type something in the REPL and show your friend like, hey man, look, I made a calculator. That's usually not the stuff that you want to share with Elm. What's great about the language is it's really oriented around doing stuff on the web. And what's great about the web is the web's really oriented around sharing stuff with your friends. So what I'm going to show you today is how can we get a web page up and running, written completely in Elm. So when I was using string, and when I was using char, and I was using char, when I was using numbers, those are all types that are kind of in the core of Elm. Those are things that Elm uses. But Elm's libraries actually add more things we can do. So let's actually take a look at that. I don't know how to exit. Exit? All right. So yeah. So what we're going to do here is we're going to make a new folder, and we're going to call that Hello World. And this is just going to be our first introduction to how we can use Elm. So back to the Elm commands that are available. We just did Elm REPL, so that kind of gave us an ability to play around with the syntax, get kind of used to that, and get real-time feedback about if I type something, what can I expect. Next, we're going to do Elm init. This is going to create an Elm project from scratch. So I'm going to do Elm init, and it's going to say, hey, we're going to create an Elm JSON file, and if you have any questions, go to this link. Are you okay with me, creating that file now? We're going to be okay with that, so we'll type Y, hit enter. Internet's down again, so I wonder what's going to happen. Elm's pretty good about downloading stuff ahead of time, so I don't think we're going to run into any real issues with this, but dang, does it make things slow. Cool. So we created our project, so I'm going to do ls, which is going to print out everything that we have in this folder, and I'm actually going to open this up in Visual Studio Code. So code dot is going to open up this current project over here. Visual Studio Code is just a text editor that I use. You might use Atom or whatever. But what's great about Visual Studio Code is it's got these awesome extensions, and I've got the Elm extension. So I'm going to show you. It's trying to hit the internet. We're just gonna stop that. So yeah, so I have this Elm language support extension that's going to give me syntax highlighting and cool stuff like that. So you might see my colors are pretty. And what's also cool about VS Code is I can do control backtick, and I can actually get our terminal in here, and we can do all of our work kind of in this one spot. So if I create a new file, main.elm, .elm is the extension for Elm files. So .js is JavaScript, .html is HTML, .css is CSS. We're only going to be dealing with this one extension, .elm, and we can write all of our code in that. So every Elm application usually has a main module, and that's like the entry point to the app. And modules are basically files, and those files can expose functions that are visible. So public functions and private functions that we want people to be able to call. So if someone imported main, they'd be able to call this lowercase main, which is going to be the main function, which is like the entry point of the app. So what I'm going to do is I'm going to basically create some HTML that says hello world. So just like we called add before, we're going to use this function called text, and the function text we're actually going to get from another module called HTML. So HTML is a module that comes with Elm. It's basically we've got our dependencies here. Elm HTML is the package or the library that we're using. So we're going to be able to use this HTML module to create text. It takes in a string, and what it does is it spits out some HTML. So if I save this, I've got Elm format, so it's indenting stuff for me. But basically you'll see it's going to take in a string, and it's going to spit out some HTML. And so on our screen, hopefully, we'll see hello world when we run this in the browser. Back to the Elm commands that are available. The one we're going to run to create a kind of like a live or interactive session is Elm Reactor. So Elm Reactor is going to basically run a server on port 8000. And then if we follow that link, we're going to get this view. And this view is going to allow us to click on our file and see what that looks like in the browser. So we're going to click on main.elm, and here we have hello world. And what's cool about that is if we made a mistake, let's say we didn't give it a string, we gave it a number. When we refresh this, it'll give us our error in the browser. So I guess back to the successful thing. If we see what we created here, all we created was a text node. So inside of our body, we've got hello world, and this is just a script tag that runs Elm for us. This isn't that interesting. But if we wanted to create something like an H1, that's a type of HTML element, we can do that. We can say, hey, I'm going to want to create an H1 element. It's going to have no attributes. It's going to have a list of no attributes, and it's going to have a list of children. So most functions in Elm HTML will take in a list of attributes like class or ID, or if you're making a link, maybe it's like href or something. So our attributes will go in this list, and then our children will go in this list. So we'll take a look at what that is later and build an intuition around that. But what that means is when I refresh, what we're doing here is we're saying, hey, let's create an H1. And the child of the H1, what's going to go in between the opening and closing tag, is just going to be some text. So we can do this for all kinds of things. Anything you can think of in HTML, that's just a function in Elm. So H1 is a function that takes in a list of attributes and a list of children, right, separated by spaces. So these are the spaces that separate the arguments. What we can also do is we can say, hey, let's make a div. It takes in a list of attributes, and its list of children is just going to be one child, which is going to be H1. So once you learn how to do it once, you can kind of keep doing it. Syntax is still probably new and weird, but we're gonna get better at it as we go. So there we go. We've got a div. It's got an H1 as its only child, and that H1 has this text as its only child. So to make that more clear, I'm gonna do some weird indentation stuff. It's gonna look strange. Elm puts the commas on the left. This is a subtitle. But basically, if we want to have two children in this list, we just separate it with commas. So this is how you might write that in JavaScript. Or you might write it like this. Or you might write it like this. But I've got this Elm format thing that's going to format the code to look like what I want to in Elm. So when I save this file, it's gonna kind of snap it into place for me, so it looks like any other Elm code you might find on the internet. But basically, this div, let's give it an attribute real quick, just to show you the importance of that first list. So I'm going to import all the attributes. This is just another module provided by the HTML library, and that's going to give us things like class, ID, and things like that. So maybe I have a class which is app, and class is just a function that's going to take in a string and convert it to a HTML attribute. So here our div's got this attribute class. It's got two children, hello world, and this is a subtitle. And each of its children just have one child, just that text node. So if I wanted to give this an ID, I would do this here. I'd say title. So you see the attributes always go first, and the children always go second. And what's cool about that is Elm can warn you when you make a typo. So unlike HTML, if I made a typo here, I wouldn't really know about it until runtime. So Elm won't compile unless all your things are typed okay. And what it's really great about is giving you a suggestion of like what's the nearest word that you might have meant. What's the thing that you could have meant there. So here we have our first naming error. Actually, we saw it earlier with null, but this error is basically saying, hey, I can't find the clause variable. Maybe these are the things that you want. So yeah, so it turns out we did want the first recommendation. It was class that we were trying to do. So that kind of gives you a guarantee that things aren't going to be or happening in an unexpected way when you get your code up and running. So that's kind of an intro to making views with Elm. So I'm going to stop the video there, and then in the next part of the series, we're going to do something real. We're going to make a button that when you click it, it's going to do stuff. And that's going to involve us making a program. So yeah, thanks for watching, guys. I'll see you in the next video.